Hello and welcome back. In this video, we're going to work on finding the image characteristics of an object placed in front of a converging or a concave mirror. The object is going to be placed at various points in front of the mirror, and we're going to focus on the image characteristics. That means its location with respect to the mirror. In other words, what kind of image it is. Is it a real image or is it a virtual image? We're going to state whether it's upright or inverted. Upright means an object or an image that is showing is being right side up. Inverted means upside down. And whether it's enlarged or reduced. Okay, enlarged means bigger, reduced means smaller, or the same. It could be the same size. Right? So we're going to be looking at those things as we do this, okay? Let's begin. I am always going to draw my incident rays in different colors. I'm going to draw my incident rays, my reflected rays, and my back rays. Something to consider. Always draw a back ray extension from all reflected rays. So all reflected rays are going to have this virtual ray extension leading back into the mirror. I call that a back ray. So every time we draw a reflected ray, we're going to draw a back ray. Please use a straight edge or a ruler to complete this activity. Here we go. I'm going to color code everything. I'm going to make my incident rays in black, my reflected rays in blue, and my back rays are all going to be gray. Okay, so I'm going to color code everything. I would highly recommend that you use colored pens or pencils or highlighters accordingly. Let's begin. Ray number 1 goes through, and I'm going to use two different rays. The first ray goes parallel to the principal axis, like this, and then reflects through the focal point, just like this. Draw it nice and long. Okay, so the black ray is the incident ray, the blue ray is the reflection off of the mirror. Remember to draw a back ray extension of the blue ray. So the gray dashed line is the back ray. So just to kind of label so we can get the terminology down, applying to other examples, this would be the incident ray. This would be the reflected ray. This is what I am terming as the back ray. Okay, make sure you draw all three of them every time. Now the first ray will never change. It goes parallel to this thing called the principal axis, which bisects the mirror, and then it reflects through this point called the focal point. That's the first ray every time. Now the second one is a little bit weird because the second one goes through the focal point and reflects parallel. But sometimes that second ray doesn't always work, depending on where you are, where the object is relative to the focal point. When you get really close to the focal point, this ray doesn't really work. So instead, I'm going to use the third ray, which goes through the center of curvature and reflects back up on itself. So I'm going to draw a ray from the top of the object all the way through the center of curvature. And as soon as I hit the mirror, I'm going to reflect it back on itself just like this. It's a very easy one to draw. And then again, I draw the back ray coming from the back side. Okay, now let's use our words. Let's use our language. The back rays are diverging. They're spreading apart. The blue reflected rays have converged. And they've converged at this spot right here. So what we do is we go from the principal axis down to the point of intersection, and we draw an arrow to that point of intersection, just like this. Now, since the arrow is pointing downward from the principal axis, this would be an example of an inverted image. In other words, the image will show up upside down when projected on a screen. This arrow is clearly smaller than this arrow. This arrow represents the object. This arrow represents the image produced from the mirror. And this object could be your face in front of the mirror. It could be anything. It doesn't matter. The point is, it's represented by an upright arrow. In this example, the image arrow is inverted and it's smaller. It's reduced. Since it occurs in front of a mirror, this is an example of a real images. Real images always happen in front of the mirror. Real images also happen by the intersection of reflecting rays. Virtual images happen by the intersection of back rays, which means virtual images always form behind the mirror. Let's take a look at question number 2. In question number 2, we have the object placed at the center of curvature. Now, it's going to be pretty tricky. I can't use the third ray. I'm going to have to use the second one in this example. But other than this second example, the third ray is very handy to use. So I'm going to go between using the second and third ray. First ray never changes. We're going to go parallel to the principal axis, and we will reflect through the focal point. Draw your back ray. The second ray is a converse of the first ray. The second ray goes through the focal point and reflects parallel. Again, draw your back ray. You'll notice your back rays again have diverged. They're spreading apart. And your reflecting rays have converged at that point right there. We draw our arrow to that point. We can see we have an inverted image because the image is upside down. And it's not really enlarged or reduced. I'm going to say it's the same size. It's about the same size as the original object. And again, it's real because it's in front of the mirror. Number 3, we're now moving the object closer to the focal point. So we're halfway between the center of curvature and the focal point. First ray, parallel to the principal axis, reflects through the focal point, draw it nice and long, back ray. Second ray, through the focal point, reflects parallel. Draw your back ray. Again, ladies and gentlemen, you should notice how your back rays are diverging and your reflecting rays are converging to this point over here, producing an inverted, enlarged. The image is now bigger than the object. Real image because it's in front of the mirror. Okay. Moving on to number 4, what happens when the object is placed at the focal point? All right, so first ray, parallel to the principal axis, through the focal point. Second ray is not going to work because you're at the focal point. If I put a line straight down, it's not going to hit the mirror. So I'm going to go right to the third ray. The third ray is the ray that goes through the center of curvature, but it's going to line up back through the center of curvature. So I'm going to line it up back with the center of curvature like this, and it's going to hit the mirror somewhere up there, and it's going to reflect back down through the center of curvature like this. And what you should notice is your back rays are parallel and your reflected rays are parallel. In other words, we have a very unique situation in which no image is formed. In order to form an image, you have to have either reflecting rays intersect or back rays intersect. It has to be one of the two. Number 5, we've now moved the object halfway between the the focal point, and the mirror. Let's begin. The first ray goes parallel to the principal axis and reflects back through that focal point right there. Draw your back ray. Your second ray, I can go through the center of curvature or I can go through the focal point. It doesn't matter. I'm going to go through the focal point. Line it up with the focal point. Goes through the focal point, but this time it reflects parallel, like this. This time, ladies and gentlemen, you should notice how your reflecting rays are diverging, and it's your back rays that have converged, and they've converged to a point right above this point right here. And so we're going to draw an arrow all the way up to that point of intersection from, remember, we always draw the arrow from the principal axis, right, to the point of intersection. The point of intersection now just happens to be above the principal axis. So what do we have here? We have an upright image because it's right side up. It's clearly enlarged, and it is virtual because the image is now behind the mirror.